This is the second of the power problems, or the example problem for power. And you've got a fly, he's 1 gram, and he is walking straight up a window pane at 2.5 centimeters per second. Let's go ahead and we'll make the window pane. Here's our little fly. We know he's moving in this direction. We know gravity, the force due to gravity is down. We know that his force is up. And we also know that the change in displacement is up, or the change in distance, which is displacement, is up. So we're set there. We have to make an assumption with this. We're going to say he goes 2.5 centimeters per second. So let's just do this for a time equal to 1 second. We're going to just leave that. That'll be important later when we try to find the power. We have to be very careful because the speed is in the wrong unit. It's in centimeters per second. We want it in meters per second. So if we take that 2.5 centimeters per second and we divide that by 100 meters, we end up with a value of 0.025 meters per second. So there's the speed that we need to use. The mass, on the other hand, is also messed up. We need to make sure that our mass is in kilograms. Right now it's in grams. 1 gram divided by 1,000 grams in a kilogram should give you 0.001 kilograms. So now we have everything in our standard units of meters per second and of kilograms. At this point, we've got to go back and remember that work is equal to the change in the kinetic energy. So let's just find the change in kinetic energy for this problem. We know it would be the final minus the original kinetic energy. Our final kinetic energy is 1/2 mv final squared minus 1/2 mv original squared. The fly starts at rest, so we're going to say that's 0. We can go through and figure out what that change in kinetic energy is then. This is 0.001 kilograms times the speed, which is 0.025 meters per second, and that's squared. And we end up with a change in kinetic energy of 3.125 times 10 to the negative 7th joules. Because we said work is equal to the change in kinetic energy, we can go ahead and say that kinetic energy is the same as the work here, and this would be the amount of work. At this point, remember we did say that the fly is walking for a second, and so he goes that 2.5 centimeters, which is our distance. Our power is equal to work divided by the time. The work that the fly does, we remember, was 3.125 times 10 to the negative 7th joules. We're going to divide that by the time, and here we're assuming that they just mean a second. So this answer then ends up being 3.125 times 10 to the negative 7th. And remember, a joule per second is not the unit we want. We do want to convert that. Just make sure that it is in watts. And that would be our final answer for this problem.